So what is the next step? Once you find the x, which means you know t and b, you also know your surface normal, right? You can compute the surface normal. It's E1 cross, so the surface normal n is equal to E1 cross E2, okay, cross product. So this x is basically, let me write it more clearly, this is the t and this is the t and b. TB found from here, n is found from cross product, so now you can uniquely define the t, b, and space. Okay, and this is the TBN matrix. When we do texture normal mapping, we multiply the normal that we get from the texture with this matrix. Okay, so to write this final form, let's say n new, let's say new n is going to be equal to TBN matrix multiplied by n coming from the texture. Let's write n text. Okay, so this n new is going to be matched, is rotated. N text is the input, and n new is going to be the rotated vector that matches the orientation of the surface on which we are applying a new normal map. Now this is for triangle. To do the same, we can do the same thing for a sphere, and we will learn how to do that. But the computation of the tangent plane is going to be different, because for a sphere in ray tracing, we don't have UV parameters directly, right? We can compute it from the theta and phi, and we will learn how to do that. But let's leave that sphere discussion later, up to after we have talked about bump mapping. So next we are going to talk about bump mapping.